Okay, we're live. This is Toby. We're gonna continue the work on making a deep zoom post-mortem debugger. Um, okay, this time the pause button is there. Other times it wasn't. This is YouTube is weird, but whatever. Software is buggy. I'm trying to do the work to make software less buggy. That's my grand vision. The reason I'm making this thing is I'm trying to make software less buggy by giving people a way of debugging that will help them understand their program better. Yeah, I would say that in one sentence summarizes why I'm doing this and what I'm doing. Okay, so right now I'm actually pretty excited because I have basically realized my vision of this deep zoom debugger, which sort of um, sort of came to me when I was thinking a lot about uh, Benoit Mandelbrot's uh, concept of fractals, the deep zoom, Google Earth, etc. And at this point, basically you can have a program, have this visualization of the runtime of a program. So there, every program has one single entry point, maybe. I don't know. Okay, that might be debatable, but let's for the moment let's assume that's word true. Um, you can zoom into the entry point to see its serious steps that it takes, starting from its entry point. But along the way, some of the steps will be these sort of sub procedure calls, and you can zoom into those to get the more detailed steps. And then sub procedure calls will have more sub procedure calls, and you can zoom into those, and then zoom into those, and then zoom into those, and then zoom into those, etc., etc. Um, at infinitum, if you will. So now, if you drill into the base case, you're gonna see that in the base case of this recursive function, it eventually returns a concrete value here. So fib of 0 returns 0. Is that true? Should fib of 0 return 1? I don't remember. But fib of 1 return 1. I don't know if this code is correct or not, but if it's not correct, well, that's why we have a debugger here. Okay, so this is very cool. This is very cool. In terms of the user interface, there's plenty of enhancements that are needed. One in particular is that I actually want it to be like um, either nested under each line or to the right of each line. Whenever there's a variable assignment, such as this line, I actually wanted to say, hey, and that variable got assigned to whatever it should have been. In this case, I guess that would be 1, 2, 3. That would have been 3, and in this case, this would have been 2. So whenever there's an assignment, I want I want immediately apparent right next to or right under that line to tell you what the variable received as its value. Uh, and perhaps in perhaps I think I should do that for returns as well. So whenever there's a return statement, I also want to tell you, hey, the return value that was what was it, like 3 and 4? The return value was 5. I want to tell you right there, right next to or right under that line, right away. Um, and that's fairly straightforward to do. I already had code to do that. And I can sort of either re-implement it or bring that code back to do that fairly straightforwardly, I think. So I'm gonna add that to my to-do list actually. Oh, that's right here. That's right here. Yep. Um, so that's what I want. That's one of the things that I want. What are other things that I want? Um, oh, I was debating whether, like, the fact that this if statement, when it skips the body of the if statement because the condition was not met, it skips the body of the statement. That kind of looks weird because I have this unfinished if statement in there. I was thinking I should add the rest of the if statement into this display, but maybe gray out the lines that were skipped or something. So that's something I might do. Although after looking at this for a while, I kind of like the fact that this output has fewer lines of code than the actual code. That kind of makes it easier to comprehend in a way. There's a concept called program slicing. I don't know if you've heard about it, which actually, this is actually doing exactly what program slicing is. And program slicing is the concept that um, if you went into if you look at the execution of a program, uh, you can actually, based on a set of criteria, sort of simplify your program by taking out some of the code. If you know what a particular value is in the execution of the program, then you can only trace the lines that it's executed and not and sort of remove the lines that don't matter. And that's kind of exactly what this does. This is I implemented tracing in the runtime of the program to trace every single line that gets executed. And and it's not that I explicitly threw away the lines that didn't get executed. It's just that those lines didn't get traced. Um, but and this concept of program slicing actually is a technique for to help programmers understand large programs easier, because you can sort of say, let me see what happens to this function if I throw the value of 0 at it, and then you see that, oh, only these lines get hit if you throw 0 at it. But if you throw 5 at it, then a different set of lines get hit. And that helps you understand the program more. And sometimes, because it removes the dead code, you can sort of get a intuition about what code is relevant to your situation right now and what code is not relevant. So there's something about this display where it just throws away the unexecuted code that I do like. So maybe this is not such a bad thing after all. Um, and also, like, if you get to the base case here, if you get to the base case again, you can very clearly just see exactly, oh, it only did 3 things, and this is what it did. And you don't have to bother with reading through all of the code to try to mentally calculate out exactly what the program did. These are the 3 things that it did, and that's exactly what it did. It didn't do any more than that, so you don't have to worry about it. There's something that's really nice about it. In this session, I think I'm going to try to make that performance enhancement that I wanted to make. Actually, I was planning on it in the morning already, and I sort of drew out all the diagrams and spent a lot of time explaining it, only to switch direction after lunch and do something completely different, which also solved the problem. But right now, I actually think there is value to solving the first problem that I was going to work on this morning, which is that, again, has having to do with performance still. Well, actually, in the morning, the problem I was trying to solve was a bug, not a performance problem. And but now I'm wanting to solve it for the performance reason. So the thing I want to solve is that um, I drew out in my last session where okay. If I can have the concept of the current scope. So during the rendering process, this render frame entities, each time render frame entities is called, it's asked to render a particular frame. I think the first one is going to be, well, there's a outer main, I believe. I'm not totally sure. And then this one is for main. And then inside of main, there's a FIP7 for this particular program. It depends on the program, obviously, but for our toy example, it's been FIP7 so far. And then I have FIP6 and then FIP5, and then within FIP6, I'm gonna have FIP5 and FIP4, and then within here, within FIP5, we're gonna have FIP4 and 3, etc., etc., etc. It all goes all the way down. So the idea was like, well, there's all this execution that's going on. If we can reduce this execution if, like, we have this print FIP7, right? At the outermost layer, we have something like def main. If the viewport is all the way zoomed into FIP7, there's actually no need to render any of this stuff out here. We can just start laying out the stuff within this box right away. There's no need to process anything for this main scope, which is the outer scope here. We can just start right away, starting from here, and that would kind of reduce the execution time, which is basically saying, like, if the viewport is zoomed so deep that everything within the viewport is completely contained within this scope, then we should just start the rendering at here, and then it would only incur the cost of everything within this box, and that will save us all of this stuff, and this stuff as well. We'll end up with only what is in here, which is quite a significant cost saving. So that's what we're gonna try to do. I hope it works. In the morning, I had already sort of started down that road. I think I commented out that code. Yeah, it's right here. So I'm gonna bring it back and see if we can bring it back and get it to work. It was like I was in the middle of getting this to work. So, and all of this code is still extremely messy. It's a lot of things are in flux. Everything, like dust is flying everywhere. It's not a pretty sight, but I'm very excited about where it is heading. Okay. So what this code is doing is, so previously I had, so the given a function like, given a function like here, I had looped through the AST tree and found all the places in the AST that made a function call to, except for the built-in functions like print, we ignore those, but all the places where we have a function call made to a user-defined function, such as fib, we track that and we save that into this array called call express boxes, which contains an AST node and a box being a text box. So in this case, for the FIP7, there's just going to be a text box that contains the word FIP7 in it. And this code here loops through this array and tests for each one whether it all of the viewport is contained within it, and this is the conditional that gives that to you. So this is saying, hey, I've got a text box. I've got a text box here. Is it true or not that the viewport is completely contained within my box? Is that true or not? Because if that were true, then I can sort of completely ignore the rendering of my siblings and my parent for that matter. We can just start the rendering process on me. So and that's enough. And we want to find sort of the smallest box, smallest call expression, the lowest level, the one that's lowest level that has this property where the viewport is entirely contained within me. And and I think what we want is that our render, well, this is a huge ass function. That this render frame entities function should eventually tell you, hey, this is the current scope. So it should return a current scope. What is the current scope? I think we might need a bounding box, a co-expression. We're gonna need the history entries within this nest execution. So I'm gonna define a type that is our scope. Okay. Um, okay. A scope is gonna contain a bounding box. I'll call this B box. And the scope is gonna contain a call expression. I don't have a type definition to it, and at the moment I don't care to define that. This is an AST node, and my parser was not written in TypeScript, and it doesn't have a type definition. So, and at the moment I don't care to give it type definitions. And there might be a text box, possibly. I'll just call this box. Content box? Content box. Content box is a little bit more generic, although maybe there's overly eager genericism. And then we're gonna need the history entries, which contains history, and it's an history entry array. So that's what we need for the scope, and I'm gonna say this is where TypeScript does help you when your program is getting kind of complicated. Okay, I'm gonna say it's gonna return me a scope at the end of the day. I'm gonna open the window because it's a hot dang day. And even when I open the window, it's still not that cool. Okay. And there are my knees. Okay. Okay, yeah. I feel the breeze now, so that's great. All right. So this guy should return the scope, and whatever it returns, I'm gonna plan to sort of save it as a global variable. I'm gonna show you actually where I plan to do this. I'm gonna make a variable called, I think I have a variable called viewport. Yeah, there it is. I had this as a mutable global variables, which we do hate, but for the moment, that's what we'll do, because it is a convenient way to get this stuff working. But later on, once things are more solidified, we'll probably try to just clean up the code, organize it better. Yeah. For now, I'm gonna introduce yet another sort of global-ish variable. Well, global to the scope of this main function. I'm gonna call it current scope, which will be a scope, and the top level scope. Let me think. I'm not gonna set it for now. I guess if you don't have a current scope, go into the render function. Okay. If you don't have a current scope, then currently what it's always doing, and what it's always doing, and this is doing this in a non-optimized way, is that it's always starting the scope with the top level. What's a good word for it? The top level node, which is this main guy. We're always entering the program from here, and we're always starting the render from here, and we're gonna have all these history entries that the program has executed. Each history entry is a line of code that the program has executed that we've tracked, basically. And then that tracking, I guess I explained it in a different video how that works. I'm not gonna reiterate it, but basically I need to supply this guy with the right history entries, and also a right bounding box, right, for which to sort of start rendering. Okay, so perhaps what I should do is, let me think about if I were to encode that in terms of a scope object. Let me split this screen into two. Okay, and so we need a bounding box. We already have it. It's this guy here. It does. We are converting it into canvas coordinate first, and this is a thing that we can do. So let me perhaps move this line down, and we'll just say, well, my B box is my box. It's this guy. This guy's a bounding box, which was converted from this coordinate to the canvas coordinate, based on what the viewport currently is. And then the co-expression is actually that I don't think it matters. Actually, this might be a thing that doesn't matter. I'm thinking. I think I'm gonna remove that entirely and just say history entries is history, and let it be that, and then I'm just gonna feed this into there, and I think that probably works. And then after you do that, you get a scope back. I'll call this current scope, but we actually have a global variable called current scope. So it's like if there's already a current scope, just feed the current scope into there, and you are kind of done. Well, not kind of done, but okay. So I'm actually gonna do this. I'm gonna say current scope is maybe like this. Set up current scope outside of render. And I'm gonna say current scope dot history entries, and then current scope dot box, and then I'm gonna have current scope be initial for the initial time. I'll have it set up correctly before render is called the first time. So that would be somewhere here. I have so much crap code here. I think I'm done with this stuff, so I'm gonna delete this. A lot of this stuff was used for, and I already checked it in, so I'm not gonna miss it. I think. Okay, so now I'm gonna set up the current scope. 2 box is the result of that whole thing, and then history entries is that, and that sort of can replace that piece of code, and I should see this working still. Maybe. Probably not, actually, now that I think about it. But okay. We have a lot of errors. Oh, a lot of TypeScript errors. So let me fix the TypeScript errors first. Oh, line 137. Oh, I don't need this closing parenthesis. Line 130. Oh, it's not assignable to scope. Whatever this thing you think it is not assignable to scope. Why not? Let me look at what scope is. It's a B box. Oh, I called it B box. So it needs to be called B box is what it is. Not box. Over here. Did you mean to write B box? It actually suggests, but I didn't have the patience to read down that far. Or you could blame TypeScript and say, like, why couldn't you have been more to the point? Okay, let me see. 374. And it's saying, hey, my box. I don't know what that is. I guess I could say current scope dot bbox, or I could just do my box equals current scope dot bbox, and that should be able to satisfy that problem. Okay, I think I solved that one. 145 is saying a function, I must return a value. I haven't bothered to actually return a value. So for now, wow, this is a very, very long function. For now, to satisfy it, I'm just gonna return a thing that has a B box, which is the entries, I think, and a, no. That's the history entries. And the B box is just, did I just call that box or what? I just called that box. I called it my box. Oh, good job. Good grief. I called it my box. Hey. Hey. What's going on? I'm trying to fix my program. What's up? Did you mean B-box? Does Google want to go out exercise or something? Did you mean B-box? Yes, I did mean B-box. It talks to me, see? My TypeScript talks to me. Okay, I think I fixed that. And now I can, oh no, I totally broke it. How did I break it? Let's see.
Papa, I got like 19 stars. No, 29 stars.
29 stars on chess.com?
Yeah, on Learned Life.
Oh.
That's your account. You can make your own full account. Like, you can, like, just say, for example, you can just put your username THO and then you can pick a picture and then you have your full account. You can do anything, but you can't do it in unlimited things. Well, you can change
your photo. Is that what you mean?
Yeah, you can like there's like people and you can choose one that you look like or that you like.
Oh, I see.
And you can play and you can watch any video.
Oh, you can watch videos on there.
Yeah, you can watch Win Like Magnus, but on Learned Life you can't.
Oh, why not?
Because you have to get through the lessons. So that's how full is better than half.
Oh, okay. How do you get a full account?
I forgot.
Oh, you have to pay?
No, you don't have to pay. It's just free. Google has a funny name for his full account. His name is Cold Puffy Clock.
Nice. It's so bright. Okay, and it's so hot today.
I know.
Okay, let me see. I want to try to fix my program.
Don't lock the door. I'm just gonna get that.
Okay. Alright, that was my son. Sorry about that interruption. Okay, so let me see here. Where are we? So, oh, I'm looking at the wrong file. Sorry. Oh, it's getting too bright here. I'm gonna pull the curtain back up because I can't even see my screen. It's so bright. I introduced a bug somehow, and I'm not sure why. Cause I changed was I'm gonna try deleting this, see if it allows it to work again. Although I really didn't expect that to break it, honestly. No, it wasn't that line. Okay. I think it wasn't recursing for some reason. I'm not sure why it wasn't recursing anymore. Oh, I don't think my zooming works anymore for some reason. Where did my zooming go? Because zooming is supposed to change. Let me see. Is the mouse?
Get a piece of chalk.
There's some here. Oh, you don't like this one, right?
Yeah.
Okay.
I like 70.
Okay.
And I mean, like, and down, like 60. Well, Guga said he tried a 51%.
51%. That's sweet, right?
Yeah, the lower the number is, the sweeter it is.
Got it. The zooming, I don't know if the zooming is working anymore. Did I? Okay. Stroke the rectangle. Why are things not working? History, entries. So if I had done history here in my box, that works? It seems like I've been careful with not changing too many things at once. But I don't mind just going in, I guess, and trying to debug this. So I'll uncomment this log statement. I don't actually see that log statement. What just happened? I don't see this log statement. Oh, no, I do see this log statement. Okay. And then, let's see. And then it... Okay, I'm going to uncomment this one. And then comment this one. This is how what I used to diagnose problems before. And then this is saying... Okay. I don't want that comment. Okay, let me see. Okay, if I zoom in, zooming in doesn't seem to have had an effect. Why? As in the viewport, I don't think the viewport, no, the viewport changed. The viewport did change because I printed out the zooming. Oh, I know what's going on. Okay. I actually don't. I need to recalculate the conversion. The converting the coordinate, which was done here. I actually need to redo this one. I need to redo this one at the time of render. That's what the problem was. we need to do it here. So I'm gonna say this, I'm gonna do it right here. So this is box world to screen or something, or to canvas. And that's my box, and then I'm gonna use that my box to pass into here to be rendered, and I think that will fix it. Whoa. That seems wrong. Let me. Oh, no, no, no. Whoa, whoa. What just happened? Okay, zoom in. Whoop, whoop, whoop. It became a tiny, tiny speck of dust. It happened again. Why did that happen now? Convert the. So. Oh, I see. Because. Okay. Okay. Let me undo that. Okay. At least that works again. Alright. I'm gonna run to the restroom really quick. Oh, you wanna let me open up the curtains so you can have more light. Oh, I'm still working. No,
Yeah.
Can I try to finish my session first? Okay. We'll save chess for a little bit later. Okay. So right now I need to decide what coordinate system. Oh, you want to use this one? Okay.
Who are you talking to?
People who might be watching. but probably there's no one watching right now. So I'm just basically recording myself for the future.
Do you edit stuff in your debugger thing?
No. Stop running this script. Yeah, stop running that script. Okay. Okay. Let's see. How should we proceed? So every time we call render frame entries, we're going to have to take the B box in the scope object and then convert it into canvas coordinate, which may, depending on what the current viewport is, it could be wildly different coordinates. Now, we might want to change that, maybe, because that would not have to be an issue if we had moved this call inside the render frame entries function, like as the first call to that function. However, so let me draw this out because it might be hard to. I'm kind of trying to imagine the picture in my head, and that's quite difficult. And usually, and it doesn't make for a very good explanation. So if I draw it out, then I can explain it to myself better and also anyone else. So, so let's say we start with the main scope as the current scope again. So we'll say the box is always 0, 0, and 1200 across and 1200 from top to bottom. Now within the main box, there's probably this, when there's enough detail, there's going to be this FIP7 call, which we are going to want that to be the current scope instead of the main scope. But the way we arrive at the coordinates of this box is gonna be dependent on the fit box algorithm. Whoops, not fit box algorithm is gonna tell us what are the location and dimension of this box, which is kind of dependent on what that box is after it's been converted into canvas coordinates. So the location of this box is actually going to be in canvas coordinates, and therefore it's kind of unstable. And that's kind of a problem because, well, having unstable things, it can often be a problem. But that does mean that we're not, I don't think one thing we can try is not do this guy, not do this conversion here. And then sort of when we go back, we do the reverse conversion. I'm going to try that. So I'm gonna go back on what I said. And also change the current scope. And then I'm going to, here, I put the conversion back here, box world to canvas. There we go. So we're going to convert this to canvas coordinates. And then later, we're in the render function. Render frame entries function. Maybe we convert it back. Or no, not converted back, but wait. This, when it set it back, it'll, oh, the conversion doesn't happen again according to the new viewport dimensions. That was the problem. So never mind. We do need to perform it, but perhaps we do the reverse conversion here. So reverse so world box screen or canvas to world. This is kind of crazy. Do I even have that function? No. I might have that function somewhere. If not, I'll have to write it. Okay. I'm gonna first undo back to what I had before. Then go back on my words again. Here, set the current scope to whatever that guy returns, and that guy, before it returns it, I have to convert it back to the world coordinates, which is going to be done here. World canvas to world. Okay, now I need to write this canvas to world function, which I will. Oh, I have a point canvas to world, but I don't have a box canvas to world. Okay. Let's write this function. Okay. So it should be the inverse of whatever this guy does. So this guy, what does it do? It first subtracts and then multiplies. So this should first divide. And then after the division, it should add viewport.top. So that should be the inverse of that, I believe. It'd be cool if programming languages would you can just say, hey, do the inverse of this function, and the language can do it. Oh man, that would be so cool. Maybe I can make that happen in the toy language I'm making now. Wow. You just write a pure function and you can just say inverse that function, and then you don't even have to write code. It'll figure it out for you. Okay. Okay. So I have this new box canvas to world function, and basically it'll convert backwards to where we started. And then kind of set it back for now. And I guess this code should still work, and it seems to still work. Okay, so now I want to vary it. Okay, let me. I have a lot of extra debug logs. I'm gonna remove them now. Okay. 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 I think we're getting somewhere. Maybe. So at this point, we didn't find a subscope, but I think if we zoom in far enough, a little more, then we start finding a subscope. So if we find a subscope, we're actually going to, let me see, return that as the current scope eventually. So, and this is, eventually, let's see, where do we find the subscope? Oh, here. We find the subscope here. Oh, I actually need the expression. New current scope expr. I need to remember that as well. Probably like that. And then if we did find one, then at the end, after and if one of our children has returned one, I'll call this child found new current scope. Maybe I should have a better name for this. Enclosing scope, maybe. Found enclosing scope. I'm gonna call this enclosing scope. So if there's a enclosing scope, then we're gonna actually return that one, because that would be a smaller one than mine. Let me think. And there would only be one of them. I don't anticipate multiple of these to give you an enclosing scope because that's impossible. Gonna move this variable out so that I can get it across the loop. I don't actually know the password. One second. Let me try something. Oh wait. Okay. Okay, so if this ends up with a value, then we'll return that. Else, we're gonna return else we're gonna take whatever that is to get the history entries. We'll use the expiration. So else if we ended up with a new current scope, else we're just gonna return null. Or no. Else we're gonna return that. Oh wait, are we inside of a big else statement or something? Yes, we are. Okay. Okay. I'm just gonna write it out. So history entries should be based on this guy, because this guy has a line number, has a start and then a line number. Based on that, I can get the, I think I called it nested execution. Okay, so I can get the history entries out of there, and then I'm gonna get the bounding box, and I'll sort of convert it back. The box is that of my box, and then I will return that like that. So I don't know if what's gonna happen at this point. I think let me see. It's kind of crazy right now. Whatever this guy returns is gonna, okay, I'm gonna say it's gonna return some new current scope. after rendering. I mean, it didn't change here, which that's right. Whoa, mama. What? The new scope this is saying is whoa. This is a much smaller box now. This is clearly wrong in some way. I'm not sure why it went through this path. Okay. Fallback returning my box. I'm gonna say here, I'm gonna oh wait a minute. Oh, this shouldn't have been my box. It should have been the box of whatever is that one. And we should only do this if the child has found, well, this doesn't seem right. Oh, this is a very, very small number for Y, but I think that's fine. But the problem is when we drill in a little bit more, we get this small box, which I think represents the fib. But the history entries didn't. No. It did change as well. So it kind of, if child, I'm gonna do a printout here. Maybe it went through here. Oh yeah. That would have happened. That would have happened. But let me make sure. Code puffy clock. Okay, so no, it's just falling back, returning my box. Fall back, returning my box. And my box. What is my box? Okay. Let me debug this. So, alright. I have to debug this so the hard way. Can you track the entry of these functions? Let's do this one. So, okay, we're gonna render, I think it starts here. I think it starts here with what? Oh, this one, okay, let me start back from here. So it did render frame entries for the main scope, and then it says my area ratio is greater than 0.5. So I'm gonna recursively call render frame entries with fit n equals 7 scope now. And when it says falling back, I guess I don't really know. Oh, I think I know what's going on, maybe. So the child is returning its own box, but we probably don't want to do it unless oh yeah, I actually don't want to do this. This should return null in the default case, actually. It's only if uh, you found an enclosing scope in this calculation where you're actually looking for it, that you should return anything. So, and this changes the render function as well. So this shouldn't set current scope right away. There's only if enclosing scope exists do we want to set the new current scope to it. Yes. And then in which case I'm gonna say I'm gonna print this guy out here. Updating and current scope. Oh, you're working Google? Oh no, this is not Google. Okay, nice. I think that worked. Okay. I'm gonna, well, okay. Now I'm looking for this printout that says update current scope, and I expect it to happen once I zoom in far enough. Let's see it. No, it didn't happen. The thing that would have had to happen before that one did was I actually need to wait. Child found in closing scope. Did that ever happen? No, that didn't happen. Okay, did the other thing happen? Did this happen? Yes, that happened. If this happened, then we have this box, but then after this happened, we needed later on we needed this to happen. This is, let me see, returning new found enclosing box. I guess else is a case that neither. I should, whenever I'm printing out, I should use the indent here actually. I have set up this indentation to be used in the logging. So we should use that. Neither. Alright, let me go in, zoom in more, zoom into this level where it should have found. Oh, it said updating current scope. Oh, I think it worked. Booyah. Okay. It updated the current scope to this one with the fewer entries and with a smaller bounding box. And I think that means if I zoomed out, yeah, I don't get to see the parent anymore. If I zoom in to one of these, it'll eventually also update the current scope. Did it do it? I think it did it again. And then that means if I zoom out again, I don't get to see the parent call anymore. And that's what it's supposed to do at this point. Perfect. Yes. So I can zoom very, very deep in. Yeah, zoom very, very deep in. If I zoom back out, you don't get to see the parent anymore. And in order to fix it so that you can see the parent again, we actually need to detect when the current scope, let me see, um, we need to be able to calculate the parent scope. And the time when we decide when we need to go up one level is when the viewport is no longer enclosed within the scope. Let me think. Actually, what we could do. Oh, but how does it know its parent? So that's actually a problem. Currently the child call has no way to go back up to reference its parent. So let me think about that. But um, we can probably do that in this same process where you're trying to lay out your own box here. Let me think. Well, your box is gonna actually get. So this process, if this box is gonna be not contain the viewport after having converted this box to canvas coordinate, then that's where when we know we need to pop back to the parent, and actually you can do the same calculation, see if the parent in turn still is enclosing the whole viewport. But that relationship from, let me draw this out to explain it. So we have a main is the top level scope, and then within the main we have a fib 7 scope. But then within the fib7 scope, we have a fib6 scope. Within the fib6, we have a fib5, and so forth and so forth. Currently, there's no way for this scope to know that its parent scope is that one, and so forth. So this, we don't have a readily convenient way to undo this sort of drill down, if you will. So, which is why once we drill down, we can zoom back out to see the parent. Once we drill down into fib7, we zoom back out, we can't see the parent anymore. So in order to do that, we have to allow there to be this link from the child to the parent, and there's a couple of ways I can think of how to do that. But I think this is a good place to stop for today. Actually, did a lot of made a lot of progress today on this, which I'm happy about. So next time is probably when we'll actually finish the work started here. And until next time, I will see you then. Bye bye.
Bye.